Whether you are an architect, a manager, or a developer in applied AI space working on generative AI, LLMs, and agentic AI, innovation is a very important aspect in terms of working with the latest models and frameworks. But security is equally important. This is what distinguishes production grade solutions which make a meaningful impact for customers and clients versus just POCs where you explore the latest technology, but when it comes to performing in the production grade environments, these solutions give up. So in this video, we will walk across these security and safe AI factors which, when implemented in a correct way, leads to successful projects and meaningful outcomes. Great, let's start this journey. Open Worldwide Application Security Project, OWASP, is a non-profit foundation dedicated to improving the security of software through open source projects, community collaborations, and education. This organization has identified top 10 security risks for LLM applications, which are quite informative. In terms of LLM 01, which is prompt injection to sensitive information disclosure, to supply chain vulnerabilities, data model poisoning, improper output handling, to excessive agency, system prompt leakage, to vector and embedding weaknesses, misinformation, and unbounded consumption. We will see how each one of these vulnerabilities, when we are developing, architecting, and managing AI solutions, keeping this in mind, leads to a very informative, impactful, and solution which creates a good impact for the organizations. So let's dive in. From chatbots to agentic systems, the evolution of risk has evolved. In 2023, when we had simple chatbots, information retrieval systems, and human-initiated simple chatbots, to a landscape where we have agentic AI, autonomy, rack systems, and action-oriented execution. Critical updates have become quite crucial in terms of different attacks that the systems are vulnerable to, in terms of vector weaknesses, system prompt leakages, excessive agencies out of autonomous systems, to unbounded consumption. It requires a very clear and a calculative approach to mitigate these risks. The first one, which is prompt injection, refers to any attack which attackers utilize when the prompt engineering is not done in a correct way. These can be direct or indirect, where a user is able to inject prompts which are malicious into the LLMs and get unrequired or impactful information which can have very detrimental effect for the organization. Direct prompt injections can be simple as a user writing to the LLM to provide the inherent rules in the system, or to provide all the summary of the databases or other RAG-based systems which are present in the models. Indirect injections can be hidden malicious command inside attachments, or maybe in certain data sources some commands are written which can be used in the prompts for the model to leak the information which should not be leaked in the first place. When we look at the spotlight, multi-modal injection is one of the recurring attacks, where attackers hide prompts inside images processed by the multi-modal models, in terms of, let's say, they are reading the text from the document, but at the same time they are reading images, and somewhere in the image attacker has put information which causes a threat and a prompt injection. Key defenses include the privilege control, where the agent as well as users are provided a least level of controls to ensure that there is no unrequired leakage. There is a segregation. The external sources are always marked as untrusted, and the data from those sources is treated separately. There are ingestion layers and output layers which filter it out before the data is fed into the RAG or the model prompts. There is always should be a human in the loop for approval of high risk actions. So let's look at the second vulnerability, which is sensitive information disclosure, whether it is personally identifiable information, whether it is financials or proprietary code. All of these are intellectual materials and should be treated inside or outside of the organization in a very sensitive way. We can look at this pipeline in terms of output, how it can expose this information to the outside world in the public chat window. There is a real-world tactic which is known as proof pudding, where attackers demonstrated how disclosed training data facilitated model extraction bypassing email filters. So always when developing your code, you should be looking at how you can build layers to make sure that the PII, financials, proprietary code, and other sensitive information as per your use case is vetted. It is taken out of the output and the input layers before either the information is fed into the model or the information is fed out of the model. While I have talked about the mitigation strategies, let's look at them in brief. So do not rely on the instructions. So whatever instructions you have given in your prompt, that is just first layer, and you should not rely on it completely. Never ever think that if you have told your model do not tell, it will do that, because sometimes hallucinations are caused. You have complex prompts and model might be able to overlook over it. You should have the separate or independent layers to check all of this. Do use data sanitization, scrub the sensitive information before it enters the model, and educate the users as well as developers in terms of the best practices. Now the third one is the supply chain vulnerabilities. So the LLM models or the AI models are not one piece kind of systems. They are microservices, a lot of time microservices integrated systems, where we have a lot of systems coming together to create those solutions. Apart from the LLM layer that we have mostly in clouds, we have the compute layer, we have the application layer, we have the hardware cloud, we have the base models. So at each entry point there are risks. For example, in terms of the base models, for example, PyTorch, Pickle, or any other library, you have to see whether there is no arbitrary code execution, there is no outdated library, and you also have to look at the kind of updates that have been done for these libraries, because it has to be done time to time, and whenever these are outdated or whether there are some vulnerability findings, you have to make sure that you are updating these libraries. Similarly, in the fine-tuning adapters, when we are using LoRa, in a lot of cases where it is used to fine-tune the model, at this layer in a deep neural network, some sort of dependencies can be invoked, which user might not be able to see. So a proper risk mitigation and validation layers have to be set in. Model cards, a lot of times when models are being used, there is a lack of signing or authentication. So all of your systems should be properly authenticated. For example, in terms of cloud, you should make sure that you have your models built in a way where they are in a private network. There is proper role-based access control and authentication done in those models. Similarly, the key defenses, if we are talking about those, should be in terms of software bill of materials. And this is nothing but a detailed inventory of what your softwares are, what are the different building blocks in your model, and how they are segregated together, so that when the audit happens, the developers are able to see those, different auditors are able to see those, and different project managers, testers are able to see and find out what are the detailed building blocks of the models, along with all the licensing and other related information. There should always be model signing in terms of what is the model, how that model is being used, when it was updated, and the underlying authentication and verification should be done. And vetting should be done, scan for model lab optimization and tampering. Moving on to the fourth one, which is data and model poisoning. So a lot of time when the training or optimization or RAG-based layer building of this model is being done, if there is no proper grounded data modeling and pre-processing techniques in your AI ops, a poison data can be injected into your fine-tuning layers, and sleeper agent can be created, which can cause a lot of issues in the later stages of the pipeline. For example, a user can activate a payload and because of the sleeper agent, a malicious behavior can be activated, which can exploit training dynamics, inject malicious document into the databases. So the correct way to handle this is by verifying your different building blocks in terms of data sources, fine-tunings. You should always vet outside data sources. There should be proper labeling and segregation done for the outside versus internal data, and even there should be proper manual or as well as automated pipelining done, so that this data, when fed into this model, is independent of the biases and toxicity inside it. When training, there should be a sandbox environment which is isolated from the production environments and systems. And for user data, use vector DBs. The fifth one, improper output handling. So a lot of time, what mistake we do is we focus too much on the input validation, making sure that data we're ingesting, we are vetted correctly from different governance layers. But we have a blind trust on the what AI is generating. So you should follow the zero trust principle in terms of treating LLM output as untrusted user input. There is a simple example of it where an attacker can write me a JS payload, LLM processes it, and it creates a exploit where the output is able to get accesses and SQL injection, causing a lot of damage in terms of leakage, data leakage, and other associated activities. The key defenses for this involves context-aware encoding, following the OWASP validation standards, and the sandboxed execution, so that whenever these models are operating, they are independent or isolated from the other systems, and we have independent systems to check what happened, and also those systems are not fully controlled by these particular LLM based layers. The third one is excessive agency, which refers to giving unrequired permissions to your agents, where they have the authority to delete when it should be read only. They have full read-write access for the databases, executes actions without confirmation. So functionality, permissions, and autonomy should be looked at, and these permissions, unless and until it's a typical and very important business case, they should not be given to the users, to the agents. Similarly, we can talk about a scenario where an agent reads a malicious email and automatically forwards the sensitive information contents to an attacker without asking. So let's say you have an agentic system where it has to receive an email, process it, and then after getting all the information, sending it back to the sender or the person who sent that email. If you do not have any guardrails built in terms of checking, which domain that email has come, and you are fully relying on the IT infrastructure of the current ecosystem without building necessary controls in your system, it's a big risk. You have to make sure that your input has a valid sanitization. You first check, this image is intended from the intended mailboxes. You can build subject or body level check. You can also build a layer in terms of attachment checks. And then when all of these validations are done, then only you should do the further processing and steps in terms of the process. In terms of defense, implement the principle of least privilege. Do not provide agents unnecessary privileges in terms of whether you know it or not. So you should be quite clear in terms of what permissions should be given, and you should have a well coordinated communication with the IT team to make sure that these privileges are clear, and each function in terms of your AI ops pipeline knows at what is the responsibility. And add human in the loop for high impact actions, so that humans have oversight and they can control agents from going rogue. The seventh part is system prompt leakage. As you are aware, system prompts are the prompts which are put into your solutions, telling the solutions what they are meant to do. So if you can see here is a system prompt that you are a helpful assistant and somebody has put a secret key. So in your system prompts, make sure that you are not putting unnecessary secret exposure or keys. You should never put those there, and do not put internal rules into the system prompt. System prompt should be always just to define high level working of agent, not the details. Also, there is a misconception that developers treat system prompt as a secure backend. They are not. They are not a secure backend. Backend is separate than a system prompt. System prompt is just meant for the LLM model to understand what are the high level functioning of it, so that it doesn't hallucinate at the very high level. And system prompt is not a security control. So best mitigation for this is do not put secrets in the prompt and do not put unnecessary logic into your system prompts. Now going into the vector and the embedding weaknesses. So a lot of time when we are building our RAG layer, which is quite important layer in terms of how the grounding and customization is put into your AI solutions, these RAG architectures have certain risk. For example, embedding inversions, reconstructing text from vectors, knowledge conflict, Poisson vector, manipulating retrieval. You can see one example here in terms of user A data, cross-tenant leakage to user B data, and then these vectors get corrupted. So you have to make sure that the vector ingestion and indexing and retrieval pipeline is always well architected. Whenever there is a constant and continuous update in your vector DBs, you should have proper controls built to make sure that these kind of confusions and cross-tenant leakages do not happen. We can look at the scenario which happens for a quite while text on a white background indexed by vector DB poisons the hiring recommendation. So there is a clear instructions provided in the prompts along with the system messages, but in your vector DB in the background somebody has put some malicious Poisson data which lets the updation in the prompt and leads to hiring recommendation which should not have been done in the first go. The defenses are clear: permission aware vector stores, and there should be cryptographically secure storage. So as it is interlinked with your supply chain of AI, you should ensure that you have proper RBAC built, you have proper ingestion layers built, there is clear authentication and authorization, there is a principle of RBAC there. Users should not have, or developers should not have unrequired access to these vector DBs, and you should always ensure that there is no conflict in terms of how these vector DBs are being updated from different sources. You should have a proper ingestion layer and the indexing, embedding, and the retrieval layers built. Now in terms of misinformation, so we have done a lot of talks in terms of how you should build your LLM solutions, how you should make sure that the supply chains are good, and how you should make sure that input and the output ingestions and instructions are secured enough. But what if after all this your model hallucinates? How do you make sure that you are preparing yourself for that risk? So there are simple steps for it, so that you are not just focusing on quality, but you are going into security and liability aspects of the models. So let's take an example for this. LLMs hallucinate non-existence packages are introduced which attackers then register with the malware. Right? This is quite a possible scenario where the LLMs are being used for vibe coding, and they give through those packages which are vulnerable or non-existent, and which leads to attackers then attacking with the help of those. How do you ensure that these are taken care? Because this can lead to liability risks. And we can see in case of Air Canada, chat got fabricated refund policy leading to successful lawsuits. So you should always use RAG for grounding. You should have cross verification of the information, and you should have explicit warning for the users before they use this AI information. They should vet it. There should be final approval before the information is being used. Now let's look at the last one, unbounded consumption. So let's say now you have your model is doing good. You have built a secured input, output, your supply chain is secured, you are able to take care of the risk and liabilities from the generation of the model. But what if your payload varies? What if in a solution where you have just 10 transactions per day, you get 10,000, and instead of one attachment which you get every time of 2 KB, you get 200 MB attachment for this 10,000? What is the model gonna do? Because apart from denial of service that this will cause, it will lead to bankruption of the cloud budget. because attacks are no longer just about crashing servers. These are about bankrupting your budgets. The cost and the budget limits skyrocket all of a sudden if you do not have these layers built into your solution. The attackers, how they work is sends inputs with long complex contacts and force expensive GPU operations, and the impacts are clear in terms of financial exhaustion, energy consumption, service degradation, and loss of reputation. What are the defenses? Put the rate limiting in your cloud budgets. Put budgeting caps. See if your model, when it is spinned up, you have a rate limit defined, and beyond that the model will go out of scope. At least that time it will not cause too much of volume, which can cause unrequired bankruptcy of the cloud budget. And build notifications and monitoring systems which can detect this pattern, and they can inform the operations team and the developer team so that they can take necessary steps. Great. Now, if we look at this from a bird's eye view, we can see when we are visualizing this attack how it surfaces with an Generative AI stack. We can look at how this looks, from injection to prompt leakages to disclosure of the information to underlying platform supply chain risks to the model poisoning to output data handling to excessive agency, and then to the prompt leakages, and then to the vector weaknesses, misinformation, and consumption. We can see how this impacts your entire pipeline, and if you are visualizing this in a correct way, how it can lead that in the building of a very comprehensive and impactful solution. Because I mean, directly or indirectly, all of these best practices will lead you to build very informed code. As a summary, if you look governance and the path forward, have the adversarial testing done, make it mandatory. Continuous probing should be there for logical flows on a timely manner, and you should have AI bill of material for every deployment, where you are aware of what are the different building blocks of your models, of your supply chain, what are the licensing agreements, what are the versions of the different frameworks and the libraries being used, so that in case of any adverse event there, you are able to detect it and you are able to trace it to the vulnerability, and then you are able to take steps at the right time and right place to mitigate the impact. The framework alignment is also important. So to align with the framework like NIST or NITRE, it's very important. So security is a continuous process, it's not a checklist. So this should be kept in mind. And while you are developing your solutions, if you keep these standards in mind, then definitely you're going to have solutions which will have greater impacts, which will be appreciated by your customers, and it will lead to building of trust, mutual respect, and impact among your teams and your customers. I hope this video gave you the required information. If it had an impact in terms of your knowledge and how you would work in future, please like this video and subscribe and share. Thank you.